This is our EOC practice. We are in part 2. This is the part that actually allows calculators. We're picking up on number 6. It says a small high school class of 9 students were told they will receive a pizza party if their class average is 92% or higher. So that's the first part you got to look at, 92% or higher on the next exam. Then it gave us the scores from students 1 through 8, from 86 through 96 as they're listed. There are 9 students, and they need to find an average. The average is 92% or higher. So the way we're going to do this is we're going to take all of those scores, 86, and we're going to add them together. Plus 91, plus 98, plus 83, plus 97, plus 89, plus 99, plus 96. Now that's the 8 scores they gave us. 1, 2, 3, 4, 5, 6, 7, 8. But it doesn't say there are 8 students. It says there are 9 students. So there's one more student. We don't know what that student scored. So since we don't know something, anytime we don't know something, we represent it with a variable plus an unknown score. That'll be student number 9. If we're talking about the average, you add all of those up and you divide it by however many scores there were, 9. So when we add all of those numbers up, we get the number 739. So I'm going to simplify this, shorten it up a little bit to make it fit a little bit better. But 739 plus x, that's the one we don't know, divided by 9 has to be greater than or equal to 92 in order to get the pizza party. Anytime it says at least, or it says 92% or higher, that means greater than or equal to. So we have 739 plus x is greater than or equal to 92. Get rid of divide by 9. So multiply by 9 and it'll cancel this out. If you multiply that by 9, make sure you do the same to the other side. 92 times 9 is the number 828. So now we have 739 plus x is greater than or equal to 828. So in order to get x by itself at this point, all you need to do is undo this positive 739 or plus 739 by subtracting it. Do it on that side, make sure you balance it out and do it on this side, and x is greater than or equal to 89. Again, as you're looking at your answer choices for something like this one says x is less than or equal to, less than or equal to. We know it has to be greater than or equal, tells us that it has to be greater than 92. So you can automatically get rid of A and B and give yourself a 50-50 shot between 87 and 89. Number 7 says Zandra went to a candy store to buy jelly beans. She wanted 3 flavors from the 12 they sold. It says how many combinations. Let the word combination be your key word. If you see combinations, or if you see orders, or if you even see the word permutations, which you probably won't see. All of those words kind of go together. And again, this is a lesson that we kind of skipped over. Give you a quick little run through on it though. 12 combinations of 3 different flavors. So you're going to set it up just like this. Set it up with however many numbers you start with, which is 12. And since it's combinations again, we're going to set it up as 12 combinations C. And you do a little 12 and a big C like that. And it's combinations of 3. And you can even read that just like that, 12 combinations of 3. Now, if this was talking about 10 people running a race, for example, and you wanted to find out how many combinations of first, second, and third people can be in, you would do 10 combinations of 3 because it's first, second, and third. You would redo that one as 10 permutations of 3 over, because combinations always become fractions like this. You have to do a little bit more work, but they're going to be smaller numbers over, and whatever number this is right here, 3, that's the number you start with on the second one, 3 permutations of 3. So that's talking about the races. And the one we're looking at, the jelly beans one, it's 12 combinations of 3. We're going to change that to 12 permutations of 3 over, again, you start with whatever number is the second one, 3 permutations of 3. So all you have to really know is how to set the top up, and then notice it's always going to be 3 of the same number shown. So this tells you to start multiplying by the number 12. So this equals, let me get rid of this out here. This equals 12 times, and we're going to multiply it by the next smallest integer, or the next smaller integer. So 12 times the next number is 11, times the next number is 10. And you can keep going and going and going forever until you get to 0, no matter what number you start at. But since it says permutations of 3, we only want to do 3 numbers. 1, 2, 3. So that's where we're going to stop on the top. The bottom one, just like we started with the number 12, it told us to start with 12. We're going to start with 3. So 3 times the next smaller number 2 times the next smaller number 1. Again, you're going to go 3 numbers, 1, 2, 3. So when you multiply these out, 12 times 11 times 10, and divide it by 3 times 2 times 1, which is 6, you're going to get 220. So there are 220 combinations to choose from. Number 8 says using matrices. What is the solution to the system of equation? We skipped over matrices, or the plural of matrix in here. All that is like 1, 2, 3, 4 plus 2, 3, 4, 5. We skipped over it because it's a simple concept, and it's something that you'll be able to pick up when you actually need to use it. This just tells you this is the left one at the top. You add it to the left one at the top. So you do 1 plus 2. This is the right one at the bottom. You add it to the right one at the bottom. You just do its positions. Again, we didn't go over matrices, so it's not necessary to solve this one using matrices. Just solve it using a method of your choice. Now, you have 2 methods that we've actually learned 3 methods, but 2 of them are actually useful. Graphing them really isn't all that good of a method. We can eliminate this by making opposite terms, or we can substitute things in. Now, we know that these both have, or all 3 of these, I should say, have 1 as their coefficient. If you're eliminating it, you're going to make one of those sets of coefficients opposite of each other. So you want to make -3 the opposite of whatever's in front of the x at the bottom. Or you want to make the 1 at the top by the y the opposite of the 1 at the bottom. That's probably the easier one since they have the same number. If we take this top equation and we multiply it by -1, since we want to multiply this one by -1 to make that -1y. Notice that makes them opposite terms. But you can't just multiply it by the term you want to. You got to multiply it by everything. So -1 times -3x gives you a positive 3x times this one we did. And -1 times -2 is a positive 2. So now if you ignore that top equation and you only look at these 2 equations, we'll get where we need to get. 1x plus 3x. Now all you do is combine them. 1x and 3x is 4x's. 1y and -1y eliminate each other. That's what we were trying to do by combining it. There's no more y's. Equals -6 and 2. When you combine those, you get -4. So now it says -4x equals, 4x equals -4. Get rid of 4 times something by dividing it. Do it here to balance it. X equals -1. So we have the x value at -1. As you're looking at your answer choices, there's only one that has an option with the x value, remember it's x comma y, as -1. So it's going to be the answer B, but if you're not satisfied with that and you want to keep working it out, you can. Plug in x's value into one of the simpler equations. This looks like the easier one right here. X plus y equals -6. And just take that value, -1, and drop it right there. So -1 plus y equals -6. Get rid of -1 by adding it. Make sure you do it to the other side to balance it. And y equals -5. Now you have x comma y, or -1 comma -5, which again is B. Number 9 says to simplify the square root of 45 times, I know we usually use a dot, times, you'll see an x sometimes, times the square root of 27. You can multiply these 2 numbers and get a great big number and then simplify it. Or you can think to yourself and say, well, wait, they both have perfect squares already in them. The number 45, remember your perfect squares, 2 times 2, 3 times 3, 4 times 4. We'll stop there because we want to use 3 times 3. The square root of 9, notice we didn't lose any radical symbol, times the square root of 5. When you multiply those 2 by each other, you get back to the square root of 45. The square root of 9 is 3. Notice it's outside of the radical symbol, times the square root of 5. We can do the same thing with the other one. Again, the same perfect square goes into it. That's a coincidence, but it doesn't make a whole lot of difference. The square root of 9 times the square root of 3. Again, the square root of 9 is 3 times the square root of 3. And now we have much smaller numbers to deal with. Multiply what's outside of the radicals by what's outside of the radical. So 3 times 3 is 9. And multiply what's inside of the radical times what's inside of the radical. So the square root of 5 times the square root of 3 is times the square root of 15. You have one more question to ask yourself. Is there a perfect square that is a factor of 15? That means, can we multiply any of these numbers or the numbers that come after those by something and get 15? No, we can't. There's no fractions involved, so this is your simplified answer, D. Number 10 says, Cammy bought a large basket of 60 bananas. If she brought them home, 4 of them were rotten. If she goes back and gets 200 more, how many rotten ones should she expect in that bunch there? So there are 4 rotten ones in 60 bananas. If you set this up opposite this, watch, it's still going to come out to be the same. So this is saying out of the total, how many of them are rotten. So all this is a probability. It's your favorable outcome over your total. Again, it's not positive to have something be rotten. You don't want them to be rotten, but that's what you're looking for, so that's why we call it the favorable outcome. So 40 over 60 equals how many out of 200? That's what it says. How many rotten ones should you expect? Once you have your proportion set up, go ahead and cross multiply. 4 times 200 is 800. And 60 times x is 60x. In order to get x by itself, divide by 60 on both sides. And x equals 13.3. Says how many rotten ones should you expect? And I think that the question, actually, I just shortened it up for you to copy. I think it said about how many rotten ones should you expect. This is the only one that actually works for us, 13. Number 11 says, if f of x equals 7 minus 6x, then f of negative 4 equals how much? Anytime you see this, everybody, don't freak out. We don't use that term a whole lot in here, but we have seen it before. All that means is y. So if you want to look at it again, y equals 7 minus 6x. And then it says, if f of is f of negative 4. That means in place of x. So it says f of x, you plug it in place of x. So 7 minus 6 times negative 4. So negative times a negative is a positive 24, and it's being subtracted from 7. 7 minus 24 is negative 17. Number 12 says solve this following inequality. Distribute negative 3 times 4x is negative 12x. Negative 3 times 5 is minus 15. We'll bring our greater than symbol down. 5x plus 6 plus 13. There's no reason to have a parentheses in that set there. You want to simplify everything on the left and everything on the right before you try to move anything across. We can't subtract 15 from negative 12x, so the left side is considered simplified at this point. There's one thing we can do to the right to simplify it, though. We could add 6 and 13 and get positive 19. Bring everything else down. Now you want to bring your variable terms to the left side. It makes it a whole lot easier when you're dealing with inequalities. So move your 5x to the other side. It's positive 5x, so subtract it. If you subtract it on the right, subtract it on the left. That gives you negative 17x. Still minus 15 is greater than. These will cancel, 19. Move everything else to the other side, so get rid of minus 15 by adding it. Do the same thing here. So 19 plus 15 is 34. So we have negative 17x is greater than 34. In order to get x by itself, it says multiply by negative 17, so divide by negative 17. If you do that on the left, make sure you divide by negative 17 on the right. Now, here's one of the things you have to be careful with inequalities. Anytime you multiply or divide by a negative number, your symbol has to change from greater than, the way it's written, it has to flip around and become less than. These will cancel and give you x. Positive divided by negative is a negative 2. So x is less than negative 2. If you solved it the other way and you had your variable on the right-hand side, it's okay. Just make sure that you read it the correct way. So if you came up with something that looked like this, make sure you don't leave it in that form and say x is greater than negative 2, because it's not. It's x is less than negative 2. B. Number 13 says, what is a solution to the following system of equations? This one actually sets itself up easier to use substitution because you have y equals all by itself. So take this value of y, 2x, and just plug it in place of the other y. So what you have is 2x equals 4x minus 8. Get your x's by themselves, so subtract 4x on the right, do the same on the left. Negative 2x equals 8, equals negative 8, and get rid of negative 2 times something by dividing by negative 2. Do the same on the right. Negative divided by negative is a positive 4. So x's value is 4. That's the first one. Again, x comma y, you notice you only have one answer with an x value of 4, but we'll go ahead and find a y value just in case people are skeptical about it. Y's value equals 2 times x. Bring that number 4 and drop it in place of x. So y equals 2 times 4. Y equals 8. So x comma y, 4 comma 8. 14, we're simplifying 3x squared minus 5x plus 6 minus. This minus is key right here because it's going to make you do the opposite of everything you see inside the parentheses. So 3x squared minus x squared is 2x. We're putting those two terms together because they're both x squared. 2x squared. Negative 5x minus 4x is negative 9x. And positive 6x minus a negative 7 means plus a positive, so plus 13 is actually squared. 2x squared minus 9x plus 13. Not a whole lot of figuring for that one.